All right, so now let's go over significance test for the difference between two means. So the name of the test is a two-sample t-test for the difference in means. Now, we could technically have to run a two-sample z-test if they give us the two population standard deviations, if those are somehow known. But, in practice, those are rarely known, so I'm not even going to cover that in our notes. So we're going to usually use a z-test, okay? The null hypothesis is that the difference is going to be 0 against the alternate that the difference is going to be greater than, less than, or not equal to 0. One-tailed, two-tailed. Again, a BAPS question beyond AP statistics, we could hypothesize a difference that is not 0. Something else, something different than 0. But that won't, that's not a standard question. Same for assumptions. Test statistic is always your estimate or your statistic minus a hypothesized difference divided by the standard deviation of your statistic. This is my estimate. This is the standard error of my estimate. This is the hypothesized difference. Okay? Same structure, just putting in different numbers. And there is our crazy degrees of freedom. Okay? This is our, I don't know, 6th go around now of this, so we really should be pretty good with this. So here's an example, kind of an already worked out example in your notes. After buying many helium balloons only to see them deflate after a couple of days, Aaron and Jenna decided to test to see if helium-filled balloons deflate faster than air-filled balloons. To find out, they bought 60 balloons and randomly divided them into two piles of 30, filling the balloons in the first pile with helium and the balloons in the second with air. Then they measured the circumference of each balloon immediately after being filled, and then they measured the circumference again after 3 days. The average decrease in circumference of the helium balloons was, so this is the average decrease in circumference, and this is the standard deviation of the decrease. The average decrease in the air-filled balloons was 2.1, and the standard deviation was 2.97. So this is going to be a little ridiculous, but they're going to ask us if this is a significantly different number than this, when these are my standard deviations. Yeah, I think this is one that we could maybe do without even using a calculator. There is definitely going to be a significant difference. If our spreads are this small, we got 30 in each pile, sample size is a 30, this is a huge difference. But we're going to run the test anyway. Do these data provide convincing evidence that helium-filled balloons deflate faster than air-filled balloons? P, parameters. Mu sub h is going to be the true mean decrease in circumference after 3 days of helium balloons. Notice I didn't say the true population mean. That would technically be incorrect because if we read this, I didn't do sampling from a population at all. I bought 60 balloons, not randomly. I just went and bought a bag of 60 balloons. And then what did I do? I randomly divided them into two piles of 30. And then I applied a treatment to each of those 30. This is an experiment. Experiment without sampling. So I'm not going to be able to generalize to a greater population. Instead, I can just prove causation. Basically, the causation is, does air-filled balloons deflate, or helium-filled balloons deflate faster? So the true mean decrease in circumference after 3 days for helium balloons. I don't like how this doesn't reference like a greater for all helium balloons, like the balloons I bought. I'm being a little bit picky here, but I don't really like how I did this. The true mean decrease in the circumference after 3 days for all helium balloons, like the balloons I bought. I don't want to reference the 30 balloons in my sample. This is bigger than that. So maybe I should have said something like this. Ditto for air-filled balloons. The null hypothesis is that mu h minus mu a is equal to 0 against the alternate that do the helium balloons deflate faster? So if they deflate faster, their circumference is going to have a bigger decrease. So is the mean decrease for helium greater than the mean decrease for air? I said H minus A, so if I move the A over on this side, that is a difference greater than 0. Conditions, number 1, the balloons were randomly assigned to the air and helium treatments. Don't say random sampling, it will be wrong. And yeah, just gotta be careful your wording. 10% condition, don't do it. Independent samples, don't do it. This is an experiment. Normal large sample. Thankfully the girls chose, or girls, Aaron, whatever. Thankfully the girls chose sample sizes of 30, so that's just big enough to make the large sample size. So you can just kind of go check. Again, this is not needed. I like it, but it's ultimately not needed, so let's just not do that on the test. Because if you try to do that on a test and you mess anything up, it's wrong. I guess I'll read it to you. By the central limit theorem, the sampling distribution of the difference in my sample means is approximately normal. Sounds nice if you word it right, but name the test. This is a 2-sample t-test for the difference in means. This, and this all came from the calculator. Okay, so let's do this here. Menu, statistics, stat tests. This is a 2-sample t-test. Do I have the raw data or the stats? Well, if I had the raw data, I'd have a list of 30 decreases for helium and a list of 30 for air. I don't have that. I have the statistics. Gosh, I'm not going to be able to remember these means. I'm doing helium, so 26.5. I can't do that. 26.5. Standard deviation 1.96. 1.92. Sample size of 30. 2.1. Yes. 2.79. Sample size of 30 for the second group. Alternative is that the first is greater than the second. Let's double check that. First is greater than the second. Good. Never pool. Degrees of freedom, 51.4. Degrees of freedom, 51.4. Don't forget to put that on your paper. That'll cost you a point on my test. And I think on the AP, I'm not real sure. Depends on the rubric. Test statistic, 39.46. Now, this is a Z curve, not a T curve, but T curves are very similar to Z curves. They're just a little bit more spread out, but we're talking this is 1 standard deviation maybe, right? This is 39 standard deviations above the mean. That area is going to be super, super small. So, and then our p-value is 1.98 times 10 to the negative 40th power. So that's 0.0000, 39 zeros and a 19. So this is overwhelming evidence. P-value is less than 0.05, reject the Ho. We have convincing evidence that the, copy this down, is greater than, copy that down, that the true mean decrease in circumference after 3 days in helium balloons is greater than that of air balloons. So that I use that to kind of save me some writing. I do think we should put something about for balloons like the balloons in this study. I don't think the AP test is too picky about that, but I don't know. I got to be careful, I guess. We should talk about what we can generalize to. We can't generalize to a larger population. We can just generalize to balloons like the ones we bought in that little bag. So helium balloons deflate faster than air balloons. Okay. Paired t-test versus a 2-sample t-test. Okay. I'm going to stop the video here and handle this later. on the next video.